Welcome back, everybody. Ready for another deep dive?
Absolutely. Let's go.
Today, we're looking at something pretty cool. I think I'm pretty excited about this one.
Mhm.
It's called LLM2CLIP, and basically, it's all about combining
Yeah.
large language models with CLIP
Right.
to make CLIP even more powerful. So we're talking about better image search,
Yeah.
more nuanced understanding of images, maybe even some breakthroughs in how we create visual content
Yeah.
using AI. Our main source for this deep dive is an excerpt from a research paper
Okay.
titled LLM2CLIP, Powerful Language Model Unlocks Richer Visual Representation. Catchy title.
Yeah.
So we're going to try to break down the complexities of this technique. We'll cover how it works, why it's so innovative, and what it could mean for the future.
Cool. Sounds good.
So to start, maybe you could give us a quick refresher
Right.
on CLIP and LLMs, just so everyone's on the same page.
Sure. So CLIP stands for Contrastive Language Image Pre-training. It's a model that learns to connect images and text. It was trained on a massive data set of image-text pairs, and it can do some pretty amazing things.
Pat, what are some examples of what CLIP can do?
Well, you can use it for image classification, even without specifically training it on the objects you want to classify. That's called zero-shot classification.
Wow.
Pretty cool, huh? You could also use it for image text retrieval. So you can search for images using text queries or vice versa. CLIP is also behind some of the most advanced AI models out there, like Stable Diffusion and DLE2.
Oh, yeah. Those are incredible. I've seen some of the images they generate.
Yeah. It's pretty mind-blowing stuff.
And LLMs, those are like ChatGPT, right?
Yeah, exactly. Large language models, they can write stories,
Yeah.
translate languages, answer your questions, even generate code.
It's like they have access to this vast library of knowledge.
That's a good way to put it. They've learned from a huge amount of text data.
So how did the researchers even come up with the idea to combine CLIP and LLMs?
Well, they were interested in this question. Can we use the knowledge stored in LLMs to make CLIP even smarter?
Makes sense. LLMs are language experts, and CLIP is all about understanding the relationship between images and language. So it seems like a natural fit, but I'm guessing it wasn't just...
Yeah, you're right. It wasn't that straightforward.
Okay, what was the catch?
So it turns out that LLMs, in their raw form, they're not very good
Really?
at understanding the subtle differences between image captions.
That's surprising. I thought LLMs were supposed to be these language whizzes.
They are, but for some reason they struggle with the nuances of image captions. And that's a problem for CLIP training.
Why is that a problem?
Because CLIP learns by comparing images and captions. If the LLM can't tell the difference between similar and dissimilar captions, then it can't effectively guide CLIP's learning process.
I see. So it's like CLIP needs a reliable teacher, but the LLM isn't quite up to the task yet.
Right. And the research paper actually highlights this issue with a pretty striking example. They asked an LLM to retrieve a caption, similar to people on bicycles ride down a busy street. And the LLM retrieved this caption.
Oh, wow.
A woman sits on a briefcase in the woods.
Oh my gosh, those are two totally different scenes.
Yeah, not even close. So you could see how this lack of discriminative power in the LLM could really throw off CLIP's learning.
Yeah, absolutely. So how did they solve this problem?
Well, they came up with a pretty clever solution. They developed a two-stage process called LLM2CLIP.
LLM2CLIP.
And the first stage is all about refining the LLM's understanding of image captions. Basically, they fine-tune the LLM using a technique called supervised SimCSE contrastive learning. It's a mouthful.
Yeah, it is.
I know. But basically, it involves training the LLM to better differentiate between similar and dissimilar captions.
So it's like they're giving the LLM a crash course in caption comprehension.
Exactly.
And then what happens in the second stage?
In the second stage, this refined LLM guides the CLIP visual encoder to learn richer visual representations.
So the LLM is essentially acting as a more knowledgeable teacher,
You see?
helping CLIP to understand the nuances of images more effectively.
So they're basically leveraging the LLM's improved caption understanding
Right.
to make CLIP even smarter about visuals. I'm curious how
Yeah.
well this actually works. Did they see any significant improvements?
Well, that's what we'll dive into in the next part of our deep dive.
Okay.
Tease.
But I can tell you the results are pretty impressive.
Okay. I'm excited to hear more about those results. But for now,
Yeah,
let's take a quick break.
sounds good.
Okay, so spill the beans. How much better did CLIP get with this LLM boost?
Well, they saw some really impressive results across a whole bunch of different tasks.
Like what? Give me the highlights.
Okay, so for one, image retrieval got a major upgrade. LLM2CLIP can handle way longer and more descriptive search queries.
So instead of just searching for, like, cat wearing a hat, I could search for something like a fluffy tabby cat wearing a tiny red top hat sitting on a stack of vintage books and actually get good results.
Exactly. LLM2CLIP is much better at understanding those kinds of nuanced descriptions and finding images that truly match what you're looking for.
Wow, that's pretty amazing. It's like speaking to the search engine in clean English.
Yeah, it really is a big step towards making image search more intuitive and powerful.
So what else did LLM2CLIP excel at? What other tasks did it improve?
It also showed big improvements in tasks like visual question answering and image captioning.
So it's not just about recognizing objects anymore. It's about understanding the relationships between objects and like the overall context of the image.
Right. LLM2CLIP demonstrates a much deeper understanding of what's going on in an image, and gets even crazier when you consider cross-lingual capabilities.
Cross-lingual, what do you mean by that?
The research paper found that a CLIP model trained only on English data was actually able to understand and retrieve images based on Chinese descriptions.
Wait, seriously, how is that even possible?
It's all thanks to the LLM's multilingual knowledge. It basically acts as a bridge, translating the meaning across languages. So CLIP is able to grasp the visual concept no matter what language is used to describe it.
That's wild. So I could search for images using my native language, and LLM2CLIP would understand what I mean, even if the image captions are in a completely different language.
Exactly. It really starts to break down language barriers when it comes to visual understanding.
That's mind-blowing. So where do we go from here? What are the next steps for LLM2CLIP?
Well, the researchers believe this is just the tip of the iceberg. They think LLM2CLIP has the potential to revolutionize how we interact with visual content in so many ways.
Like what? What are some of the potential applications they're excited about?
Think about how we use images every day. We search for them online, we use them to learn and understand complex information, and we even use them to express ourselves creatively. LLM2CLIP could enhance all of those experiences in really profound ways.
Okay, I'm intrigued. Give me some concrete examples. How could this technology actually change things for people in their daily lives?
Let's say you're an architect and you need to find inspiration for a new building design. Instead of searching with just basic keywords, you could describe your vision in detail using natural language, like a sustainable, light-filled structure with organic curves inspired by nature. And LLM2CLIP could then pull up images that perfectly match that description.
That would be incredible. It would be like having an AI assistant that truly understands your creative vision.
Exactly. And it's not just limited to creative fields. Think about medical researchers using LLM2CLIP to analyze scans and images, maybe identifying patterns that a human doctor might miss. Or educators using it to build more interactive learning experiences where students can ask complicated questions about images and get really insightful answers.
So it's not just about making things easier, it's about expanding the boundaries of what's possible.
Exactly. It's about unlocking new levels of understanding and creativity.
There's one thing about the LLM2 CLIP research that I think is really worth highlighting. It's the power of fine-tuning.
Yeah, that's a key takeaway.
The paper really emphasized how this two-stage fine-tuning process was essential to making everything work. But for those who might not be familiar with this concept, can you explain what fine-tuning is and why it's so important in AI?
Sure. So think of a pre-trained AI model as a student who's already learned a lot about a subject, but still needs some specialized training to excel in a specific area. Fine-tuning is like that extra training. It takes a model that already has a broad understanding and adapts it to a very specific task.
So in the case of LLM2 CLIP, the first stage of fine-tuning was all about teaching the LLM to be a caption expert, and the second stage fine-tuned the CLIP model to actually learn from that expert.
Good.
Right?
Exactly. And what's really remarkable is that even a relatively small amount of fine-tuning data can lead to big performance improvements. They tested LLM2CLIP with different dataset sizes, and even the smallest one resulted in a noticeable boost in CLIP's capabilities.
That's encouraging because it means that you wouldn't necessarily need access to these massive data sets to get good results.
Right. It makes the technology more accessible, which is great news for innovation.
Okay, let's get a little bit deeper into the nitty-gritty of the LLM2CLIP research. The paper talks about a lot of experiments where they tweaked different parts of the system to see how it impacted performance. I think it called these ablation studies,
Yeah,
right?
ablation studies.
Okay, cool. So these are like little deep dives within our deep dive, right?
Yeah.
They help us understand which parts of the system are really crucial and how different design choices affect the overall effectiveness of LLM2CLIP.
Exactly. It's all about understanding the why behind the what.
I like that. So which of these ablation studies stood out to you? What were some of the key findings?
Well, one that I found particularly interesting was the experiment where they tested different ratios of dense captions versus original captions during training.
Okay, remind me what dense captions are again.
Dense captions are those longer, more descriptive captions that we talked about earlier. They provide a much richer, more detailed description of an image compared to a simple label or a short caption.
Right, like saying a golden retriever puppy playfully chasing a bright red ball in a sunny park versus just saying dog and ball. So what happened when they messed around with the ratio of these dense captions?
What they found was that using a mix of dense and original captions actually worked better than using only dense captions.
That's interesting. I guess it makes sense, though. If you only ever see those super detailed descriptions, you might have trouble understanding the shorter, simpler ones. It's like trying to learn a language by only reading complex novels.
Yeah, exactly. You need a balance of simple and complex input to develop a well-rounded understanding.
Makes sense. So what other interesting ablation studies did they do?
They also experimented with different sizes of training data, and that's where we saw how efficient the LLM2CLIP approach really is. Remember, we're talking about fine-tuning a model that has already learned a ton from a massive data set.
Right, right.
So the fact that they were able to get significant improvements with a smaller data set of just 3 million image caption pairs is pretty impressive.
That's really cool. It shows that you don't necessarily need those gigantic data sets to do cutting-edge AI research.
Absolutely. And that has big implications for making this technology more accessible to a wider range of researchers and developers.
Okay, there's one last experiment I want to touch on. They tested different designs for something called an adapter. Can you break down what an adapter is in this context and why it's so important?
Sure. Think of the adapter as a translator between the LLM and the CLIP visual encoder.
Hmm.
These two models come from different worlds, you know.
Yeah.
The LLM is a language expert, and the visual encoder is an image expert.
Right, so the adapter is the bridge between them.
Exactly. The adapter allows them to communicate and work together effectively. The researchers experimented with different adapter designs, playing around with the number of layers and complexity.
That'll work best.
They found that adding even just one layer to the adapter made a big difference. But adding more layers beyond that didn't really improve things much.
So it's a balancing act. You need enough complexity to handle the translation, but not so much that it slows everything down.
Exactly. It's all about finding that sweet spot.
Well, I think it's safe to say that we've officially reached peak deep dive status. We've explored LLM2CLIP inside and out, from its impressive capabilities to the technical nitty-gritty that makes it all work.
We've covered a lot of ground, from the amazing power of CLIP and LLMs to the challenge of teaching AIs to truly understand image captions.
And we've uncovered some really important insights along the way, like the need for data diversity, the magic of fine-tuning, and the constant push for efficiency in AI design.
It's been a great discussion.
If you're feeling inspired and want to learn more, I highly recommend checking out the research paper for yourself. It's a fascinating read.
Absolutely. And be sure to join us next time for another deep dive into the world of AI.
Until then, keep those minds curious.
See you next time.
So let's jump into those ablation studies. One that really caught my eye was the experiment where they tested different ratios of dense captions versus original captions during the training process. Remember those dense captions?
Yeah, those super detailed descriptions.
Right, like saying, a golden retriever puppy playfully chasing a bright red ball in a sunny park, instead of just dog and ball. So what happened when they played around with that ratio? Did they find that more dense captions were always better?
Actually, no.
Yeah.
While dense captions are super helpful, Using them exclusively actually hurt performance on tasks with shorter, simpler captions.
That makes sense. It's like trying to learn a new language by only reading like really complex novels. You need a mix of simple and complex stuff to really get it.
Exactly. The takeaway there is that data diversity is key.
Yeah.
LLM2CLIP benefits from training on a mix of both dense and original captions. That way, it can handle a broader range of tasks.
Makes sense. Now, what about that experiment where they tested different sizes of training data? I was pretty surprised that they got such good results, even with a relatively small data set.
Yeah, that really shows how efficient this LM2CLIP approach is. Remember, we're fine-tuning a model that's already learned a ton from a huge data set.
Right.
So it's pretty remarkable that they were able to get even better results with a smaller data set of just 3 million image caption pairs.
That's encouraging. It means that you don't necessarily need access to these massive
Right.
data sets to get good results.
Exactly. That
Ah,
opens up a lot of possibilities for researchers and developers who might not have those kinds of resources.
absolutely. Okay, one last experiment I wanted to touch on. They tested different designs for something called an adapter. What exactly is an adapter in this context, and why is it so important?
Okay, so the adapter is kind of like a translator between the LLM and the CLIP visual encoder. You see those two models, they come from different worlds. One's a language expert, the other's an image expert.
Right.
So the adapter is what helps them speak the same language. It bridges the gap so they can communicate and work together smoothly.
I see.
The researchers experimented with different adapter designs, like changing the number of layers and stuff.
And what did they find worked best?
They found that even adding a single layer to the adapter resulted in some pretty big performance gains. But adding more layers beyond that didn't really help much.
So it's like a balancing act.
Yeah. You need to find that sweet spot between complexity and efficiency. The adapter needs to be powerful enough to handle the translation, but not so complex that it slows everything down.
Gotcha. Well, I think it's safe to say that we've officially reached peak deep dive for today. We really went deep on LLM2CLIP, exploring both its impressive capabilities and the technical details that make it tick.
Yeah, we covered a lot.
From the power of CLIP and LLMs to the challenge of teaching AI to understand images on a deeper level.
Absolutely.
And we discovered some really important insights along the way about data diversity, fine-tuning, and the importance of efficiency in AI design.
Yeah, it's been a great discussion.
Definitely. If this episode has left you wanting more, I highly encourage you to check out the LLM2CLIP research paper. It's really fascinating stuff.
Agreed.
And of course, we'd love for you to join us next time for another deep dive into the incredible world of AI.
Until then, stay curious, everyone.
See you next time.